Good morning, students. This is class 10 max class. We are going to see types of functions. First we are going to see representation of functions. A function may be represented by set of ordered pairs, table form, arrow diagram and graph form. Set of ordered pairs means we can write it in ordered pairs, that is x comma y. And table form, already know that for drawing any graph you have to draw a table xy. And arrow diagram, using the arrow diagram you can represent the functions and graph form. Next, every function can be represented by a curve in a graph, but not every curve drawn in a graph will represent a function. Every function can be represented by a curve, but every graph cannot be represented as a function. Next, vertical line test. A curve drawn in a graph represents a function if every vertical line intersects the curve in at most one point. At most means maximum one point. Here are examples. Here the curve and the vertical line touches at only one point, so it is a function. Here also the curve and the vertical line touches the graph at only one point, so it is also a function. The curve and vertical line touches at one point, here also one point, so it is a function. Here the curve and the vertical line touches at 2 points, so it is not a function. Here also the curve and vertical line touches at 3 points, so it is not a function. So in a graph, if the vertical line touches at only one point, it is a function, otherwise it is not a function. Any equation represented in a graph is usually called a curve. So this is a curve. Equation can be represented in a graph is called a curve. Next one is horizontal line test. A curve drawn in a graph represents a one function if every horizontal line intersects the curve in at most one point. For example, here the curve and horizontal line touches at only one point, so it is a one function. Here the curve and horizontal line touches at 2 points, so it is not a function. So vertical line test is used to find whether the given curve is a function or not, but the horizontal line test is used to find whether the given graph is a one function or not. Next one is types of functions. The first one is one function. The other name of one function is injection. A function f from a to b is called one function if distinct elements of a have distinct images in b. Here the example is, here see, 1 has image A, 2 has image B, and 3 has image D, and 4 has image C. So every element in A has different image in B. So it is said to be one function. Note that if for all A1, A2 belongs to A, f of A1 equal to f of A2 implies A1 equal to A2, then f is called one function. Next one is many one function. The definition is, a function f from a to b is called many one function if two or more elements of a have same image in b. Here the example is 1, 2, 3, 4. Here 1 and 2 have same image in b, a, so it is called many one function. Next one is onto function. The other name of onto function is surjection. A function f from a to b is called onto function if every element of in B has a pre-image in A. Here an example is, here every element in B has pre-image in A. So it is an onto function. So onto function means every element in B has pre-image in A. That is onto function. Note, here range of f is same as codomain, because every element in B has pre-image, so all the one are mapping elements. So here the range of f is same as codomain. Next one is 1 1 and onto function. It satisfies both the condition, means it is said to be bijection. Bi means 2. So a function f from a to b is both 1 1 and onto, then f is said to be bijection from a to b. Here example is, here 1 maps to different element and 2 has a different element and 3 has different image. So it is 1 1 and every element of B, every element in B has pre-image in A, so it is onto, so it satisfies both the conditions, so it is said to be bijection. Next one is cryptography. Cryptography means it is study of secret codes. Cryptography means study of secret codes. Next one is into function. A function f from a to b is called into function if there exists at least one element in B which is not the image of any element of A. Here an example is, here C, here E and F doesn't have pre-image, so it is said to be into function. That is, at least one element in B doesn't have a image in A. Here the range of f is a proper subset of codomain. Proper subset means at least one element does not equal to codomain, not in F. Next, constant function. A function f from a to b is called constant function if every element of A has same image in B. Here is an example. Here A, B, C, D, all the one maps to 3. So every element in A has same image in B. That is said to be constant function. Here the range of f is a singleton set. So always the range of a constant function is a singleton set. It has only one image, so it is a singleton set. Next one is identity function. Identity means same. A function f from a to a is called an identity function if each element of A maps itself. So maps itself. Identity means maps itself. Here 1 maps to 1, 2 maps to 2, 3 maps to 3. So it is said to be identity function. Next one is real valued function. A function f from a to b is called a real valued function if the range of f is a subset of real numbers. A subset of the set of all real numbers, or it is said to be real valued function. If the range is a subset of real numbers, then it is said to be real valued functions. Next one is linear function. Linear means it is a straight line. A function f from R to R is defined by f of x equal to mx plus c. Linear means degree 1. So mx plus c is called a linear function. Here there is an example for a linear function. For linear function we get a straight line curve. And next one is a quadratic function. Quadratic means 2. So the degree is 2. A function f from R to R is defined by f of x is equal to ax square plus bx plus c. The degree is 2 is called a quadratic function. For quadratic function, the graph is a curve-like structure. It is a parabola-like structure. Cubic function. A function f from R to R is defined by f of x is equal to ax cube plus bx square plus cx plus d is said to be a cubic function. If the degree is 3, it is said to be a cubic function. The graph for the cubic function is this like only we have. Next one is a reciprocal function. A function f from r to r minus 0 to r. Here r minus 0 means doesn't include 0 because 1 by 0 is undefined. So the domain doesn't include 0. So f from r minus 0 to r is defined by f of x equal to 1 by x is called a reciprocal function. The graph for the reciprocal function is here. Next one is a modulus function or absolute valued function. A function f from r to closed interval 0 to infinity is defined by f of x is equal to modulus of x. The function is defined by f of x is equal to x if x is greater than or equal to 0, minus x if x is less than 0. So modulus value is always positive. The graph of the modulus function is this one only. So thank you students.